Now, the curves x squared equals 4y, which seems to be this red one here, is equal to y squared equals 4x, which seems to be the blue one here. Okay? And what we want to do is we need to find out the point of intersection. Now, the point of intersection is where the red and the blue line equal each other. Okay? Now, what we're sort of finding the problem here is that we need to get one letter on its own. So I'm going to get y on its own for the red one, alright? So I'm going to say that y equals x squared over 4. Alright? And then I'm going to sub that into the blue one to find the point of intersection. Now, if we're looking at the points of intersection, it looks like one of them's the origin, which is 0, 0. But then we're going to have to find the other one, which is the point P. Alright? So we're going to sub in y equals x squared over 4 into the blue equation. The blue equation is y squared equals 4x. Now, replace out the y value with x squared minus 4. Okay? And we're going to square that and equal it to 4x. Now, if this looks like a pile of fun, we're going to get x4 over 16, because it was x squared over 4 multiplied by x squared over 4. And that equals 4x. I'm going to multiply up by the 16, and I'm going to get x4 equals 64x. Going to bring that over to the other side. We're going to get x4 minus 64, x equals 0. Going to factorize out x, and then I'm going to get x cubed minus 64 equals 0. Now, here's what we're going to do. The first answer, as predicted, was x equals 0. And if x equals 0, the y value, y squared equals 4x, y squared would equal 4 times 0, implies that y squared equals 0, implies that y equals 0. And that would be the point 0, 0 that we already knew. But what we're also going to do is we're going to have a look at this x cubed minus 64 business over here. Bring the 64 over to the other side, we get x cubed equals plus 64, and cube root 64. The cube root of 64 is in fact 4. So we also have the point 4. Alright? Now we also need the y coordinates. So y squared equals 4 times 4. Y squared equals 16. Now please remember that it's in the first quadrant. So this means that y will equal 4, because you don't want it to be you don't want it to be negative, because it's in the first quadrant. So the quadrants of P are 4, 4. So that's P right there, and it's 4, 4. Find the slope of the tangent to each of the curves at P. Oof. Now this is generally speaking differentiation. Okay, so we're going to differentiate. Remember, the derivative, it's the y dx is the slope. Okay, every time it's the y dx is the slope. So the first one's easy. We rearrange this to 4y equals x squared, y equals x squared over 4. Now the point P is 4, 4, which is essentially an x value of 4, a y value of 4. So differentiate, and we get the y dx is the slope, and it equals 2x, bring 2 to the front, take 1 away from the power, 2x over 4, and now sub in x equals 4, and you get a slope of 2. Y dx equals 2. Slope equals 2. Now the slope is a positive slope upwards, and that's what we're expecting of both lines. Both lines are on their way upwards. In these, the blue line and the red line are both positive slopes going in different directions. Alright, so that's the red slope, which is a positive slope of 2. I'm expecting the blue slope to be less than 2, because it looks like it isn't as steep. Okay, now I'm going to square root both sides. So y equals the square root of 4x. Using the rules of surds, I can break it up into 2 individual parts, and I can basically change that into 2x to the power of a half, and that's y. Now I'm going to do the y dx. Bring a half to the front, multiply by 2 to get 1. Take 1 away from the power of a half. Insert x equals 4 into the equation, and when you throw that in, you're going to get a value of a half, I believe. So slope will equal a half. So a half and 2 respectively. Okay. Part 3. Find the measure of the acute angle between the tangents to the curve at P. So this is pretty much, oddly enough, like a geometry question. You have, now it doesn't look like that. If I go back to the original diagram, I just sort of, what it's sort of looking for is this here. It wants those two slopes right there. Okay, and that's what it's looking for, the difference between those two slopes there. Okay, and it feels like a geometry question in paper 1, if I'm being honest. Okay. Now, and we're going to use the Tantida formula. Tantida equals m1 plus or minus m1 minus m2 all over 1 plus m1 m2. Right, now what did we learn earlier? One of them was a slope of 2 and the other one's a slope of a half. Okay, so you can let that one equal m1 and this one equal m2, and what we're going to get is plus or minus 2 minus a half all over 1 plus 2 times a half. Throw that into your calculator, you're going to get tan theta equals plus or minus 3/4. Now the difference between, you're going to tan inverse, make sure it's in degrees. I believe it wants it in, oh, give your answer in this form here. Fair enough. So theta equals tan inverse. Now it says element n. Okay, so it's going to be tan inverse 3 over 4. Okay, you wouldn't, yeah. So it's going to be tan inverse 3 over 4. Okay, cool. Now that we've got that, we're on to 3. We're on to 3b, or was that 3b? 1 second. Now we're on to 3b. Use integration to find the area of the shaded regions between the two curves. Okay, so we're going to go back to the original diagram, and I will just get rid of all this for a minute. Just get rid of all of this like it doesn't exist, and we are going to paste this question right here. Okay, now let's see what they want from us. Okay, so what we learned earlier is that this is the point 4, 4. Okay, and what we also learned is that y on its own was x squared over 4. Okay, and we learned from the blue curve that y on its own was y equals the square root of 4x, which was y equals 2x to the power of a half. Okay, now what we're going to do is we're going to integrate both of these individually, right? So if we take the area under the red region, so it's the area of, you're integrating. Now the first x value is 0, and we know that p is the point 4, 4, so we're integrating from 0 to 4. Okay, now the area under the red curve will be this area here. Okay, so if we do the area under the red curve first, we start off at 0 and 4, and it's y dx, and we know that the y value is x squared over 4. Okay, and that gives you the red area. Now this yellow area here, which I'm going to do in here, that's the area under the blue curve. Okay, and the area under the blue curve is 4 to 0, and it's going to be 2x to the power of a half dx. Okay, and then the next thing we're going to have, we're going to take those two answers away from each other, and we take those two answers away from each other, we find out the area of the shaded region, or the green region. Okay, so let's integrate this. Add 1 onto the power and divide by the new power. So it's going to be x to the power 3, and then you're dividing by another 3, so 3 by 4 is x cubed over 12. That's from 4 to 0. and then take away the blue one, which is going to be bring the half to the front, multiply by, sorry, no, it's differentiating there. Add 1 onto the power, and you get 3 over 2. Divide by the new power, which is division of 3 over 2. Now 2 divided by 3 over 2 is, bring the fraction upside down, 4 over 3 when I multiply that out. Okay, so it's going to be 4 over 3 x power 3 over 2. Okay, now here's what we're going to do next. Now, lads, you're gonna have to excuse me on this one. I hate when I do stuff like this. Alright, just to let you know, see the red curve? The red curve is this area here, right? And that's the red curve there. So I actually should have had this the opposite way around. Okay? So if you will, I'm going to move that over here, move this one over here, and we're going to move this one bit by bit over here. Sorry guys. This one over here. I would have got a negative area anyway, and I would have found out at the end of the question, but just working ahead of time, that's what we should have been looking at. Okay? So that's the 2 of them take away from here, because the red area is that's the red area, and the blue area will be the full thing, and then when you take the 2 of them away from each other, you get the in-between region. Okay, sorry about that. Now let's integrate these from 4 to 0. We're going to put in our numbers, so 4 times 4 to the power 3 over 2 divided by 3, and then that's also, and then you're also taking away when you sub in 0. When you sub in 0, you're just going to get 0. Okay, and then it's minus the other area, just the red area, and it's going to be 4 cubed divided by 12, and once again when you sub in 0 you get nothing. Now 2 of them, you're going to get 32 over 3 for the blue area, so the blue area is going to be the blue area is 32 over 3, and the red area we're expecting to be smaller. It is, it's 16 over 3. Take the 2 of them away from each other and you get 16 over 3, and then you write down units squared. Okay, hopefully that's alright. So that's question 3b done. Okay, now we're on to question 4a. Differentiation from first principles, no bother. I'll tell you what, I'm definitely multiplying this out, because I do not want to deal with that if they're asking me to differentiate that in from first principles. So it's going to be 12x squared, it's going to be minus 4x plus 6x take away 2, and it's going to be 12x squared plus 2x take away 2. Alright, and this is f of x. Okay, now we're going to go through the rules for first principles. We're now going to do f of x plus h, so it's going to be 12 times x plus h squared minus 2 times x plus h take away 2. It's going to be 12 times x squared plus 2hx plus h squared plus 2x plus 2h minus 2. Okay, next step I'm going to do is f of x plus h minus f of x. F of x being the yellow region here. Okay, I'm going to finish off f of x plus h, so it's going to be 12x squared plus 24hx plus 12h squared plus 2x plus 2h minus 2. and then we're going to take away f of x, so we're going to minus all of this. Okay, so we're going to minus all that, and we're going to get just don't mind that for a second, it's going to be minus 12x squared minus 2x plus 2. And now what we're going to do on the next step is f of x plus h plus f of x all over h. Okay, so you're going to take the two of them away from each other now. You'll see the ones that cancel. That one will cancel that one. Anything without a h goes, essentially, and we're just left with the parts that have h in it. Okay, so we're just going to be left with the parts that have the h in it. It's going to be 12h squared. We're also going to have the, what else are we going to have? We have the 24xh. Sorry, the 24hx I mean. And then we're going to have the 2h here. Now we're going to divide them all by h. Now the problem with differentiation from first principles is generally it takes up a lot of room. So I'm just going to get rid of this for a second. Then we'll get to the proper question then. Alright, cancel out the h's. Gone, 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 and gone. Okay, and we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. Alright, so it's going to be 12h plus 24x plus 2, and we sub in h equals 0, and the answer will be 24x plus 2, and that's your answer. Now if you go back to the very beginning, if you differentiate this normally, you'll get 24x plus 2 anyway. So look, you knew what answer you were getting at the beginning. Alright, and that's the full procedure for differentiation from first principles. Okay, now here's what we're going to do next. We're next going to do some more of these. Alright, so this one here looks a bit like a product rule. Right, so product rule for the love of us. So there's two distinct sections. There's the yellow section here, and the green section here. The green section, I knew to divide it like this because the green section, that's an angle. That part there is an angle, so it belongs to the cos. So I knew I had two different parts. Then I'd say this is a product rule, and in a product rule, the y dx equals u times the v dx plus v times the u dx. Now, u is equal to x squared, therefore du dx equals 2x. Okay, next part, v equals, now I'm going to write this differently, I'm going to write it as cos, now see 1 over x is x to the power minus 1, and see the squared, I'm going to put that on the outside. Okay, now please remember, when you're differentiating angles, the angle never changes, or differentiating trigonometric function, the angle never changes. Now this unfortunately is a quotient rule, is a chain rule. The 2 goes to the front, you reduce the power by 1, so it's going to be cos, cos 2 cos x to the power minus 1. Okay, now the other part that is often missing from this is you have to differentiate this as well. Alright, so to differentiate any cos rule, so example is, what happens when you differentiate cos 3x? Well, you know the answer's got, you look up what happens when you differentiate cos, and you get minus sine, the angle never changes, 3x. But then you also have to differentiate the angle. When you differentiate 3x, you get 3, and then you put the 3 at the front, minus 3 sine 3x. And this is no different. Okay? So what we're going to have here is, it's going to be cos x minus 1. We know straight away that cos turns into minus sine. And we also have to remember to differentiate the angle. And when you differentiate x minus 1 goes to the front. Take 1 away from the power. It's minus 1 x2. Okay? So that minus 1 x minus 2 is also located here. And the two of them are going to multiply by each other now. Alright? And when they multiply by each other, this is not the nicest differentiation you're ever going to do. The two minuses cancel, so it's going to be just x minus 2, and then it's going to be sine x minus 1. And if you want to change that back into 1 over x squared sine 1 over x, be my guest. And that attaches to the end of this. And we haven't even got into the into the quotient rule yet. So that's 2 cos. Now I'm going to change that x minus 1 back into 1 over x, and then I'm going to change that into 1 over x squared sine 1 over x. Now this is a very difficult question, okay? Very difficult question. It's an insane question, to be honest. I don't know what they were thinking. Oh, sorry, into the product rule, right? So let's do this. Dy dx is u, which is x squared, and x squared is going to multiply by dv dx, and dv dx is 2 cos 1 over x, and then it's 1 over x squared sine 1 over x. Now straight away we know that the x squareds will cancel each other, and this part of the question now becomes 2 cos 1 over x sine 1 over x. Okay. Now, next thing we're looking at is, we have to do phi times du dx. Now v is quite simply cos 1 over x, and du dx is 2x. So I'm just going to put the 2x here. So 2x cos 1 over x, okay? And yeah, I'd be pretty happy with that. Oh, and we forgot, v is actually cos squared 1 over x. Okay, so 2x cos squared 1 over x, right? And that's full marks so far. Now what does we want from b part 2? A tangent is drawn and at the point where x equals 3 pi. Find the acute angle that the tangent makes with the x-axis. Okay, so this is some sort of curve, right? And this x value is a positive number, 3 over pi. What is 3 over pi? 3 divided by pi, 0.955, right? So that's 0.955, right? And we want to find out what angle does this tangent make when we bring it back down towards the x-axis. Okay, that's essentially what we're trying to do. So we need the slope, is essentially what we're looking for. And the slope is the first derivative. Okay? So the slope is basically what we got here. This is the slope. Okay, so you're going to cut all this, or copy it. You're going to bring it up here. Alright, and we're going to paste. Nope. We're going to paste our answer. And here we go. Oop. Doesn't seem to want me to bring down the full thing. And that's cos squared as well. I forgot all about that. That's still cos squared from earlier. Alright. Now, I'm going to put in 3 over pi. So 2 cos. Now it has to be in radian mode because that's definitely in rad, I'd say. So it's going to be 1 over 3 over pi. 1 over 3 over pi is just pi over 3. Okay? 1 divided by 3 over pi is pi over 3. Okay? So that makes my life easy. And that's sine pi over 3. and that's going to be 2 times x. X is pi over 3, and this is going to be cos squared pi over 3. Lads, you're just going to put all of that into your calculator. One swoop, get it done. Okay, and what we're hoping for, our answer is in I don't know, I think it'll just give you as 1.3439. 34349. Okay, now we want to find this angle with the x-axis. Okay, so as I said earlier, it's just a curve and it's going down like this. Now I think we could just basically assume that it goes, so that's its slope, right? So we already have its slope, so we know that its slope is, it has an angle theta, and the opposite would be 1.34349, the adjacent would be 1, and then just tan inverse it, because tan theta is the slope, for those of you that don't know that. You don't have to do that m1 minus m2 business, you don't need to do that whatsoever for this one. Tan inverse it, and when you inverse tan that, you should get 53.3 degrees. Okay, and that's questions 3 and 4 done.